In today's system design, we are going to discuss design for tiny URL, which is one of the most common design questions during interviews. So here is our overall design discussion framework. We should first establish problem statement, then we should get alignment on requirements, and that might include, back of the envelope calculations, a few napkin maths, some tenets or invariants of the systems. We could kind of, set expectations around systems, correctness, operational requirements, and also discuss what is in the scope and what is outside the scope. Then we should, take the conversation to high level design. And as we're discussing high level design, we can discuss, after the high level design, we can discuss the low level design and some dependencies. And then if time permits, we can discuss operational readiness requirements, for example, metrics, experiments, security reviews, or durability reviews. And then we can conclude with release strategies. So for this problem, let's see, what the requirements might look like. So a tiny URL is a URL where you have, like, again, as the name suggests, it's a tiny URL, and there's an identifier at the end of the URL, and in this case, as you can see, it's Y7KEOABV, right? It's 7 characters. I think it's 7. It's 8 characters in this case, but it might vary from anywhere from 4 characters to 8 or 9 characters. Then the expectation might be that we need 100 million URLs generated per day. The shortened URL could be a combination of numbers and characters, and we could assume shortened URLs can be deleted or updated. Or it cannot be deleted or updated. And here are some basic use case. There could be URL shortening. That is, we take a long URL and return a much shorter URL. We could redirect URLs, given a shorter URL, redirect to the original URL. And the non-functional requirements could be, it should be highly available, scalable, and fault tolerant. So let's do some back of the envelope calculations for the requirements laid out in the earlier slide. So here we have write operations, like 100 million URLs are generated per day. Write operations per second would mean around 1100 requests per second. Then the read operation, if you assume like 10:1 read operation to read to write operations, then it might meet around 11,000 requests per second. And then assuming the URL shortener service will run for 10 years, this means we must support around 100 million. This is not very realistic, but again, just for the sake of argument. Then the average URL length could be 100 bytes, and storage requirement over 10 years could mean around 365 terabytes. So let's see what the high level design might look like. So first we might agree on some core APIs. So the API endpoints facilitate the communication between clients and servers. We'll design the APIs REST style. If you're unfamiliar with RESTful APIs, you should consult external materials. URL shortener primary needs would be 2 API endpoints. URL shortening, that is to create a new short URLs, and URL redirecting, that is to redirect a short URL to the corresponding long URL. So here is the URL redirecting kind of example. Moving on, again, URL redirecting. So a 30, so technical term for this is like 301 redirect. A 301 redirect shows that the requested URL is permanently moved to the long URL. Since it is permanently redirected, the browser caches the response, and the subsequent request for the same URL will not be sent to the URL shortening service. Instead, requests are redirected to the long URL server directly. A 302 redirect means that the URL is temporarily moved to the long URL, meaning that the subsequent requests for the same URL will be sent to the URL shortening service first. Then they are redirected to the long URL server. Now, each redirection method has its pros and cons. If the priority is to reduce the server load, using 301 redirect makes sense, as one of the first request of the same URL is sent to the URL shortening servers. However, if analytics is important, 302 redirect is much better choice, as it can track the click rate and source of the click more easily. The most intuitive way to implement URL redirecting is to use hash tables, assuming the hash table stores short URL, long URL pairs. A URL redirecting can be implemented by the following: get long URL, and then you consult the hash table given the short URL, and it returns you the long URL. Once you get the long URL, you can perform the URL redirect. Now, how to do the URL shortening? So let's assume that the short URL looks something like this, www.tinyurl.com /hash value. To support the URL shortening use case, we must find a hash function fx that map the long URL to the hash value. The hash function must satisfy the following requirements. Each long URL must be hashed to only one unique hash value. Each hash value can be mapped back to the long URL. At this part of the design discussion, there might be some deep dives into a few components. So I'm taking here a few examples, but there might be others. So here, like data model. In the high-level design, everything is stored in a hash table. This is a good starting point. However, this approach is not feasible for real-world systems as memory resources are limited and expensive. A better option is to store the short to long URL mapping in a relational database. Or it could be a KV store. So the figure shows, a simple database design. The simplified version of the table contains 3 columns: ID, short URL, and long URL. Coming to the hash function is used to hash a long URL to the short URL, also known as the hash value. The hash value consists of the characters 0 to 9, small case A to Z, and bigger case A to Z, containing total 62 possible characters. So when n is equal to 7, the 62 to the power of n is around 3.5 trillion, which is more than enough to hold 365 billion URLs. So the length of hash value is 7 in our case. Now, hash plus collision resolution. To shorten a long URL, we should implement a hash function that hashes a long URL to the 7-character string. A straightforward solution is to use well-known hash functions like CRC32, MD5, or SHA-1. As you can see in the diagram, the user inputs the long URL. There's a hash function. It creates the short URL. If it exists in DB, then you can, go back to the starting point and add some predefined string to, just make sure, you don't collide again. And if it doesn't exist in DB, then you can save in DB and you're good. So base 62 conversion. Base 62 conversion is another approach commonly used for URL shortener. Base 62 helps to convert the same number between its different number representation system. Base 62 conversion is used as there are 62 possible characters for hash value. So this table kind of captures the the differences between hash plus collision resolution and base 62. For base 62, the short URL is not fixed. It goes up with the ID. The option depends on the unique ID generator. The collision is impossible because ID is unique. It is easy to figure out the next available short URL if ID increments by 1 or a few entry. This can be which can be a security concern. So continuing our deep dive discussion. So here are the steps. So in step 1, long URL is the input. Then system checks if the long URL is in the database. If it is, it means the long URL was converted to short URL before. In this case, the fetch short URL from the database and you return it to the client. If not, long URL is new, a unique ID is generated. Convert the the unique ID to the short URL with base 62 conversion and create a new database row with ID, short URL, and long URL. To make flow easier to understand, let's look at a concrete example. So suppose the long URL is Wikipedia system design. So the unique ID generated is so and so. Convert the ID to short URL using base 62, and which comes to ZN9EDCU. And you could save the ID, short URL, long URL to the database in the following manner. You could have ID, short URL, and long URL. As there are more reads than writes, mapping, the short to long URL mapping is stored in cache to improve performance. The flow of the URL redirecting is summarized as follows. A user clicks on the short URL. The load balancer powers the request to web servers. The short URL is already in the cache. Return the long URL directly. If a short URL is not in the cache, then fetch the long URL from the database. If it is not in database, it is likely a user entered a invalid short URL, and finally the long URL is returned to the user. There could be additional data talking points during the discussion. For example, rate limiter. A potentially security problem we could face is that malicious users send an overwhelmingly large number of URL shortening requests. Rate limiter helps to filter out requests based on the IP addresses or other filtering rules. Web server scaling, since the web tier is stateless, it is easy to scale the web tier by adding or removing web servers. Database scaling, database replication and sharding are common techniques. Analytics. Data is increasingly important for business successes, and integrating an analytics solution on top of the URL shortener could help to answer important questions like how many people click on a link, why do they click on the link, etc. Then availability, consistency, and reliability. These concepts again are at the core of any large system success. Hope this discussion was useful. Have a nice time. Like and subscribe for more such content.